So today we're going to start a new chapter, that is relation and functions, chapter 2. Now one thing, before starting this chapter, so during our chapter 1, in our introduction I told you something, that the sets, what was the purpose of learning sets, right? So in our first point, there was that the application of set is used in relation and functions, right? So just now we will see that this chapter is all about sets. It has everything sets in it. Wait a second, others are joining in here. So relation and functions. Now again the same thing. What is the need of studying this chapter? So first let's go to the introduction of this one. So it says, so what does it do is, here we discuss about the relationship that coexist. Everyone can see properly, right?
Yes, sir.
Yeah. So this chapter deals with the relationship that coexists between two or more objects. Suppose, like me and you guys, we are all human beings, right? So that is also kind of a relationship. So relationship that coexist between two or more objects. But we take those relationship into maths also. Like line 1 is perpendicular to line 2. Like set A is a proper subset of set B. So set A and set B are related by some way, right? So that's how we will be discussing this chapter is all about. Okay. Now the next one is, we will learn to link pair of elements of different sets or elements of the same set. So what do you mean by this one? Suppose if I say you are class 11 students, right? Now you had seniors of class 12 students. Now I can link one from class 11 student and one from class 12 student by what? By one relation, that is that you guys study in the same school, right? Clear? So that's a relation I can find. Now I can find the same relation. That means what? Different sets. Different set means what? One set is that set of class 11 boys. Another set is that set of class 12 boys. Clear? Now I can find the relation among yourselves also. Suppose I say two boys. One is Rahul, one is Rajiv. Their name starts with the letter R. So that's also kind of like a relation. Yes or no? Understand? So that's how we can form various relation between two objects. Understood? Clear? Now the next thing, we will learn about spatial relations. Spatial relations which qualify to be functions. Now this is very, very important. Functions. You have no idea. This may be the first time you will be hearing this thing. But I can guarantee you that if you want to pursue your, life goal in maths, you will be hearing functions many times. Understood? So the concept of function is very important in mathematics, as it relates one quantity to another. Just like you see time and speed. Yes or no? You can relate speed and time, right? So that's how. So we can define a function. So suppose if I say sin x. Sin x is one of the function. Now if I put, suppose the function, I will just give you a short definition of it. Suppose I say, wait, let me define a function clearly. Suppose I say f of x. Fx is a function. Now that is given by, let us say the function to be sin x. You guys heard of sin x, right? Yes or no? Please don't tell me you haven't heard.
Yes, sir.
Yes. Now if I say, can you tell me what will be f of pi by 4? Now what do you mean by pi by 4? The value. Pi by 4 is how much? 45 degree, right? So fx is a function which fx is equal to sin x. Now f of pi by 4 will be what? You see, pi, in place of x I am writing pi by 4. So in place of x, what I will write? I will write pi by 4. Yes or no? Can you tell me the value of pi by 4? Hey, sine pi by 4, how much is that? Who can tell me? What is sine 45 degree equal to? No.
1/2.
Very good. So I got a relation between that's how the function is defined. You see, this is a general function, right? That is fx is equal to sine x. Now, can you tell me what is f of pi by 2? Let's see who can tell me. F of pi by 2 will be what? Sine pi by 2. And sine pi by 2 is equal to how much? Who can tell me? Sine pi by 2. How much is sine pi by 2? Sine 90 degree. How much is that?
1.
Thank you. Yes, it's 1. That's a last one. Sine f0. Now I will not say. What is f0 equal to? F0 will be equal to what? F0 is what? By this function, it will be sine 0. And sine 0 is how much? Sine 0 is how much? Yes. So that's what function is all about. Am I clear? This one we will discuss in our next portion. Just for introduction, I gave you what are functions. Am I clear? Understood? This is very, very important. Now we move on to the first part of this chapter. That is Cartesian product of sets. You see, the first heading, you see, it's sets. From the last chapter, that idea will be using in this chapter. Am I clear? So let's do it. So what is Cartesian product of sets? Given two non-empty sets P and Q. Non-empty sets means what? They have some elements. Okay. The Cartesian product P cross Q. Now look at here. Cartesian product is denoted by P cross Q. Understood? Is the set of. Now Cartesian product is also a set. Listen very carefully. Cartesian product is also a set. Cartesian product is the set of all ordered pairs. Very, very important point. Of all ordered pairs of elements from P and Q. Let's repeat it again. Given two non-empty sets P and Q, the Cartesian product P cross Q is the set of all ordered pairs of elements from P and Q. Understood? Now how will I write Cartesian product? So P cross Q is given by. Acha, which form is this one? Which form is this one? Is it roster form or is it set builder form? Is it roster form or set builder form? It's set builder form because you see colon in there, right? So now you look at it carefully. In set builder form, what we had? What was set builder form? Our set builder form was like this. X colon. Then we write the characteristics of X. Yes or no? Everybody agrees? Please tell me. Yes. Now look at here. So this X is what? The general element, right? So in here also, in the Cartesian product, P comma Q is the general element. Understood? Where P is an element of P and Q is an element of Q. Where P comma Q is the general element. We will define, we will go through that. We will see an example. Then we will just look at it carefully. Now let's do one example. Then you will be very, very clear about it. Now you see, A is given by 1, 2, 3. Understood? Now this is what form? Roster form, right? A is 1, 2, 3. B is A, B, C. Then I want to find A cross B. The Cartesian product of A and B I am finding, right? Now you look at the elements. It is in like this, right? P comma Q. Yes or no? Just look at the elements one by one. I will discuss. Yes or no? The elements are like this, right? P comma Q. Like this form. Yes? Right? Now you see. What I am doing is 1 comma A. 1 comma A. 1 comma B. 1 comma B. 1 comma C. 1 comma C. 2 comma A, 2 comma B, 2 comma C, 3 comma A, 3 comma B, 3 comma C. Am I clear? Understood this one? Have you understood how we got this one? Now, Now I have a question. Let's see who can tell me this answer. Now I have a question. Why we have 1A in here? Why not A1 in here? Let's see who can tell me. Why don't we have A1 in here? Why 1A? Why 2A? Why 3A? Who can tell me? Huh?
Because of that pair
Because the pair. What pair?
or that pair.
Very good. Because of the ordered pair and because the A is written first, right? It is A cross B, not B cross A. Am I clear? That's why the elements of A are written first and elements of B are written second. Understood? Am I clear? Okay. Now if I do the cross product of the same set A cross A, it will be what? 1 cross 1 comma 1, 1 comma 2, 1 comma 3, 2 comma 1, 2 comma 2, 2 comma 3, 3 comma 1, 3 comma 2, 3 comma 3. Have you understood? Have you understood about ordered pair? Am I clear? Yes. Now there are some important points that you must remember. First point is two ordered pairs are equal. So what do you two ordered pairs are equal? What do you mean by that? So suppose I have an ordered pair A comma B that is equal to C comma D. So these are two ordered pairs. Yes. These two pairs are equal if and only if. It means what? If and only if the corresponding first elements are equal and the second elements are equal. What do you mean by that? Who can explain me? What do you mean by that? Tell me about this. What do you mean by that? When can these two be equal? When can these two be equal? What they say in the first point? The corresponding first elements are equal and the second elements are equal. So what do you mean by here? I am saying A comma B is equal to C comma D. So what do I mean? Who can tell me? It means that A is equal to C. The corresponding first element is equal. It means A is equal to C and B is equal to D. Am I clear? Understood? Two ordered pairs will be equal only when their corresponding first elements are equal and corresponding second elements are equal. Understood? It's very easy. Okay. Now let's move on to the second one. Acha, Na means what? Yes? Somebody said, sir. What happened? Acha, na. Na means what? Na means what? Number of elements of the set A, right? Understood? Can anybody tell me what is Na in here? Na is 3 in here, right? Okay. Now, if number of elements of set A is P, number of elements of set B is Q, the number of elements of the Cartesian product of A and B is, just multiply this P and Q. So it is PQ. Understood? Clear? Now look at here. Number of elements is what? 3. Number of elements of B is 3. So number of elements of Cartesian product of A cross B will be 3 into 3, that is 9. Look at here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Understood? Okay? Clear? Now you see here. If I have A cross A cross A. Now here we have twice, but here I am doing the cross product of thrice. So that will be denoted as A comma B comma C. It won't be ordered pair. It will be known as ordered triplet. Am I clear? There will be 3 numbers in there. Understood? Clear?
Yes, sir.
So let's move on to the exercise. So that's it. So this is all we had for this Cartesian